I'm lost on this one, honestly.
Um, so I would say, like I told you, that is an open end, and so one of the things that could be that we can say that softwares that need to be that can be used to deal with images is actually need an extensive design skills, or this graphic software design software is actually expensive. That is to me that's funny. Also, one of the things that we can say as an answer is that uh, image files can come in formats that invalid format, or a format that cannot be decoded or opened or edited. Another possible answer, I would say that image files can become corrupted and maybe not possibly able to edit and work with. Okay.
Yeah.
So that is yeah, some of the possible answers. Let me see here. Yeah. Okay. So Leo, I would try a different approach this time. If you don't mind, I would like, this is the questions. Okay. I would like to see you writing answers for these three questions. I will pass these three questions now to you, and I would like to see you writing an answers for them. Um, uh, I have seen smart people that actually, when they try to write an answer, they need slight advices here and there. So just let me confirm that you are perfect as I can see. Okay, I will send you that specific slide on your WhatsApp, and then let's see. You can share please with me, and just any text editor should be fine. So Leo, I'm facing some difficulty here. So yeah, yeah, okay. Did I send you the correct? So which? Okay. So the first one outlines the need for a translation process from a higher level language to a lower level language. If you prefer to answer the C one, okay, fine, proceed with that. Yeah, explain one problem of maintaining legacy systems.
Yeah, I was going to answer the higher level language. Yes. Well,
Okay. So it's typically a good answers. I would say I would give it 70 to 80%. 75 I'll be rather to make myself more practical. I would say you have to also understand that we are not translating to lower level languages. We are translating to machine code. Okay, never to lower level language, because even lower level language like assembly language have to be translated to machine code. Sometimes they consider C++ as one of the lower level languages, and even C++ and assembly, it need to be converted to machine code. Okay, so assembly need assembler to be able to convert it to machine code, and for example, C++ need a compiler to be able to get converted to machine code. Do you know what's the difference between a compiler and interpreter?
a compiler as well, like takes the file language and like converts it into a format that the computer can understand.
An interpreter?
I'm not sure.
Okay, so the big difference between a compiler and interpreter, both of them actually translate a language, programming language, from its high level format to a machine code, both of them. But the big difference is that interpreter executes the code line by line. It means that if there is an error on line number 10, for example, you will see that your code is actually being executed. If you do print statement, it will become printed out. And then when he go to line number 10, when there is an error, then he would show you, oh, I stopped executing, there is an error, and I will show you the error. But if we are using a compiler, actually the compiler will look for all the errors first and try to see if there is an error. He will show it to you, and he will convert the language to a machine code one shot. But interpreter, he translates the language that we write, and this is very clear in Python. Every command or every programming language command that we write in Python is executed line by line. So it means that if there is an error in a maybe line, like I said, line number 10, then when it is translated to a machine code, then we will discover that it is a problem. Before that, everything will be executed fine. But in Java, no. In Java, if he cannot compile, then he will stop and he will tell you, oh, there is a problem here. And if you make a single mistake in maybe a semicolon, or you forgot certain things, certain data types that you try to use without assigning a value to it first, then he will not run, he will show you an error. So that is the big difference between a compiler and interpreter. Okay, interpreter
Yes.
So execute line by line, compiler have to check everything first before he start to execute. Does it make sense?
Yes.
Okay, so now I would say that here not so much a perfect answer. See, typically, I would say, okay, there is still a hardware that is being produced for older version of legacy software. Yes, there is. It's not only about a newer hardware, because if we are talking about this kind of system, like I told you, they run on something called mainframe. Most of the time, something like that. Okay, And this, you can see it in possibly banks and possibly old hospitals. And this is very clear in systems that hospitals and banks that have been running from the 1970s and 1980s. Okay, and that is still running until now, up and running until now. So the problem is actually finding programmers to be able to maintain that systems. There is no possibility of upgrades. You're not able to upgrade or increase the processing power. You are just able to find uh, uh, maybe replacement parts for your hardware. Yes, that's possible. But to do upgrades, no companies is going to produce for you a new um, or upgraded hardware that you can use with your system. So that's not possible. You are not able to scale your solution because maybe you only can find one or two programmers that is able to maintain the system and to keep it running without issues. But you are not able to upgrade. You're not able to do actually a scaling for your system. Scaling means that um, um, it's kind of upgrade. So if, let's say, if you have a branch or two branches of the bank that is operating on the same software, if you want to actually make 10 branches work, so that could be a big issue. That's not possible. Okay. 10 to run slower. Okay. Yeah. Okay. So the main problem, like I told you before, legacy system actually it's very hard it is costly to maintain, but it is more costly to also or to more risky to actually upgrade or even to replace. Okay. Now legacy a new system can run alongside, which require much more resources than running one. Yes, this is correct. So do you know why it requires more resources?
Well, if you have to
So
run like two systems at the same time, like alongside each other,
okay,
then
assume that it is a hospital. What does it mean that we are running two systems at the same time?
you're running two systems at the same time in a hospital, then every time you get new data, you have to input it into both systems.
Perfect answer. Okay, that's good. And yes, and so even if you're running two systems at the same time, inputting the same data, but the migration and the testing and validation to a new system, it will take so long time, and it's also costly, and also it is an overhead. Um, yeah, so you do have to mention, I believe, some more lines here and there. Um, but in general, this two is this one and this one. Um, this is the one that need only to be that need more attention from you. But other than that, it should be fine. You can close and let me share this. I believe we already talked about that. So the difference between a normal system and a mainframe. A mainframe is a big computer it's having all the processing power, and they use something called dump terminals. This dump terminals is only like a screen and a keyboard, and it got no CPU at all. It's just tied to the mainframe, and the mainframe have this all CPU things, and this is just a dumb terminal. It means that they use it for data entry, for entering the data, and there is no processing power at all. Where the normal servers, you find, yes, the server that have a CPU inside, but also the workstation can be just a normal PC that also have its CPU and processing power. But typically, even if they do certain processing, everything also need to be checked and confirmed from the servers. Let me see here what else we can. Yeah. Now, I would like to understand from you, why is it hard to secure a system? If you have a Wi-Fi system, why is it hard to secure that?
Securing a Wi-Fi system.
Yes. Or even securing, yeah, let's talk about Wi-Fi for specific, yeah.
Well, if you're talking about Wi-Fi specifically, because it's wireless, it's a lot more susceptible to attacks from outsiders compared to wired systems.
Okay, and if we are talking about securing a system in general?
Difficulties just in terms of in general is that there
If you
is
have a
a very
website that you would like
wide.
to, yeah, okay, continue, please.
There's a very wide range of potential ways that security can be breached. So it's very difficult to be able to plan for all of those.
Okay, okay. So, I would say there is a common saying that every system is actually safe or secure until it is breached. So it means that you are safe at the moment until somebody try to break into a system. Because if somebody try to break in, or being consistent and planning to break in, he will eventually be able to break in. Not every security hole is covered, and not every protection is actually being planned. And most of the system and that is created by programmers is actually not secure, because most of the programmers actually don't really care about the security side. So now, do you know why we need to use one-factor authentication? Or not one factor? Okay, so you need a password and username. This is typical. But why we add two-factor or three-factor?
So why we would need each of these?
Yes.
Well, in general, the more factors there are, the more secure a system tends to be.
And
Uh,
what
well,
can be used as a two-factor authentication?
a two-factor, an example would be uh, whenever you log in, a verification code is sent to your email, which you can then use to verify your identity.
Okay. And yeah, one of the common examples at the moment that they typically use, there is something called Google Authenticator that you are able to use on your phone. This Google Authenticator, you are able so this Google Authenticator app, it is common for many websites. So it means that using one app, you're able to tie it to many websites. And for every website, he will create a 6-digit number that you are able to copy it when it is required from you. And yeah, so that is one of the things. And the three-factor authentication, they use a biometric factor like fingerprint. Okay. And I would say they say that one-factor authentication is something you know. Two-factor is something you have, which is machine code, sorry, like a code that is sent to your phone. And three-factor is something you are. It means that we're talking about biometric something, or facial recognition, or even scan for the eye. So are you able to tell me what do you know about web and WPA and WPA2? This is for Wi-Fi
Like,
encryption.
it's forms of encryption on Wi-Fi. Yeah.
Okay, and okay, let me go there. So web is actually dead, and it is depreciated in 2004, and it's no longer used. And then we another two forms of if encryption is used, and from 2006 we are using WPA and WA2, sorry, and it is replacing WPA. And that is one of the forms that is used for encrypting the signals of the wireless, the Wi-Fi. Let me see, introduce. Let me see what else we are able to. Okay, I think for me, I'm almost done today. So tell me, Leo, how is it? If you have any other questions to me today, or you have any requests that you would like to have in the next classes?
Would it be possible to look at a bit of paper 3 as well?
Paper 3. Okay. Yeah,
Yes.
yeah. Okay. So did you go through paper 3?
Yes, in class.
Okay. And what is the most challenging to you?
Well, so far it's mostly just been like taking notes and then solving practice questions. I think it's less about like specific aspects that are challenging and more so just like wanting to just like go over it just to like check my knowledge, I guess.
Okay. Have you tried previous questions or previous
Yeah.
exam practice questions?
Yeah, I've tried practice questions. They were provided in class.
Okay. 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 Yeah, we can look at that. Yes. Okay. So yeah. Uh, any other questions before we close?
No.
Okay. Then see you then next time.
Thank you.
Okay. Bye bye. Take care.